Hello, everyone. We have finally reached the exciting stage where we'll start building the smart AI car that will race against us. As I mentioned before, what we are going to create today will be on a completely different level from the simple systems. And believe me, even in paid training courses, you will not find content that explains what I'm about to do or in the same way. I had previously considered making it paid content or a paid add-on on Fab, but with great hesitation and effort, I decided to make it free. Maybe in the future I'll make it membership exclusive or develop it even further before doing so, but for now, it's completely free. So I really hope for your strong support by subscribing or even leaving just one encouraging comment. In this mini-series, we'll start by making the car follow the spline path. Then we'll add enough intelligence for it to reverse or change its route when facing obstacles. And later on, we'll make it overtake cars in front of it or avoid obstacles such as walls. In the next stages, we'll customize the behavior of each car so that it feels like it has its own personality, fast and bold, or slow and easy to beat, depending on the difficulty we define. As for this video, we'll learn how to make the car follow the path and also control how much it slows down when approaching turns, in addition to improving the sounds and effects we created before. If you haven't seen them yet, I'll leave a playlist for the entire series above. So today's video will be easy and full of creativity as usual. Let's begin. First, we need to set up the vehicle blueprint. I'll simply copy it from the one we've already been working on. If this is your first time watching me, don't worry. You can start from scratch by creating an empty vehicle blueprint and placing your car in it, or you can follow this video to learn how to do that. The only difference is that by copying it, I won't have to recreate all the effects for the AI, which, by the way, are just visual effects that don't affect the logic we'll be implementing, such as the sound, the collision sparks, and the skid marks. So, first, let's remove the things we don't need. We won't need the setup movement, and we won't need this widget either. I'll remove this whole section as well. As for the rest, let me see. Yes, we'll keep what's left. I'll remove this function entirely because the AI vehicle has its own way of moving. Next, let's create a new actor. I'll add a spline and a billboard so that I can later know where the path begins. I already made a custom icon for it, which you can see now. I'll scale it down a bit. Yes, that's good. Now we need to place it in the world along the track we created. But a small warning. The point where you start drawing the spline will be considered the spawn point for the path, so it's best to define your starting position carefully. For me, I prefer it to start here. To make things easier, I'll switch the viewport to top view. Just make sure it matches the path you already have. Click on a spline point, then hold Alt to create a new one, and continue until you finish. This part will be a bit boring, so I'll fast forward it. After finishing, make sure all the points align properly with the track and are neither too high nor too low. And with that, we're done with this part. I'll rename the car here. Now, let's set up the car's movement. We'll use set throttle input from vehicle component. This simply defines the car's speed, and its value ranges between 0 and 1. Connect it to event tick. Let's test it by setting it to 1 and placing the car on the track. As you can see, the car moves, but it only goes straight and fast. Now, if we lower the value here, as you can see, it moves slowly, slower than my internet. Before moving to the next step, I'll disconnect all the effects since we don't need them for now. So, now that we know how to make the car move forward, it's time to make it follow the spline path we created. Let's create a new function. I'll name it Get Path Steering. We'll create a variable for the spline we placed earlier. From Spline Path, search for spline. I'll add a return node and move it aside, since we'll need it later. Here's the idea. We first need to know the distance the car has traveled along the spline using getDistanceAlongSpline at location. Then we'll get the world location of the car along the spline using getLocation at DistanceAlongSpline. We also need to know on which side of the spline the car is. That's important. So we'll use getRightVector at distance. Then we'll use multiply, but we can't just multiply by any number, so I'll use selectFloat twice and create two variables. Max distance right, left. You'll understand their use later. I'll connect one for the right side and another for the left by multiplying it by -1. We'll create another variable. For now, just know that 0 means the center of the path, 1 means the right side, and -1 means the left side. We'll use this logic to connect it here. Let's go back here and add the two values together. What I'll use later is find look at rotation. To determine the rotation of the spline point relative to the car's position, then get delta rotation with the car's actor rotation. We'll only need the z rotation, but before connecting it, we'll use map range clamped from -10 to 10 and map it to -1 to 1, since steering only accepts values between -1 and 1, 1. The values like 10 determine how strong or responsive the steering is at each point. You can change it if you want. Connect it to the return node, and we're done. Now go back and use the function we made with set steering. We'll also need to set brake input to 0, but only once. Let's test it. Okay, what's going on here? Ah, yes, I forgot to disable this. Looks like it's not working with a few errors too. Give me a moment to check. All right, I see the problem. I strangely forgot to assign the spline path we're moving on. Just make the spline path variable visible and assign the spline in the world. Yes, looks like it's working now. Let's move the camera closer. Again, what the heck is that? There's an annoying issue, so I'll just trace it manually with you. As you can see, it's actually following the path smoothly, and even if it drifts off a bit, it realigns itself again. Before continuing, let me show you something important about the spline. If you go to this option and enable it, it's simply a visual helper inside the editor that allows you to see the curve's shape and direction more clearly. If you later find a section far from the track, it's best to adjust it because the car will follow it exactly. Currently, the car moves at the middle of the path. So let's go here and change this value to 1. Honestly, it might be better to make it visible so we can control it from here. Now the car moves on the right side of the path, and at -1, it moves on the left side. You can adjust how far it stays from the center using this variable. Okay, there's a small issue. Yes, probably from here, which I forgot to mention earlier. This value defines the default offset from the path. It's best to set it to 500. Good, it's working. Let's increase the value more this time. Nice. But it's annoying to have to manually set the direction every time, right? So, let's build a system that automatically detects which side the car is on and continues accordingly. This is important because we'll need it later in upcoming videos, so don't skip it, guys. Let's create a custom event and name it Find the Side of the Road. Just like before, we'll get the car's location along the spline, same steps, But now, we'll subtract these values and use dot product, the brilliant node that literally solves half of my problems in Unreal Engine. We'll divide it by 1000 because the input value was in meters, and I hate seeing too many zeros. So if the value is greater than 0.2, that means we're on the right side of the road. If it's less than negative 0.2, that means we're on the left. And if the result is between these two values, we're in the middle. For now, we'll just connect it to event begin play. Let's test it now. Yes, good. Let's put it on the other side now. Okay, there's strong movement at the start, but it followed the correct path. Same result here. Let's check what's wrong. Maybe the value is too low. All right, everything works, but I don't like that initial jerk. Let's make it visible and tweak it several times. Yes, the initial jump is gone now. Good. Everything works, and the car follows the path very smoothly. However, as you may notice, the car loses control slightly in turns and sometimes collides with the barriers, especially on sharp corners where it's going too fast. So next we'll make the car slow down in turns. Let's create a new custom event. The first thing we'll work on is defining the minimum speed before starting to brake. Now, from the spline path, we'll use get distance again, but this time along with get tangent at distance along spline. We'll use it twice. The second one will have an added value, which basically represents how quickly it reacts to the upcoming curve. I'll set it to 1200. We'll normalize both, and then, my favorite, use dot product again. We'll then convert the result to degrees using this node. Before continuing, let me show you what it does. Of course, connect it to event tick. That crash happened because of this. Let's redo it. I'll slow the video down at the turns so you can see clearly. When the car turns, the value increases, and the sharper the turn, the higher the value. Now we'll set the minimum angle before the car starts braking. For me, I'll set it to 22. Then use Set Brake Input. Wait, I'm thinking about how to show you the effect. Yes, I know. I'll display the car's speed so we can track it during each turn. As you can see, its speed really decreases during the turns. Unfortunately, it lost control here, but that's because I set the turn sharper than it actually is. I won't change it now. I'll leave it like that. Next, I'll fix something important, the rear light effect. If we kept the old system, this would happen. Both brake lights turn on together. If you want to know how I made these lights, you can watch that video. So I'll create a new custom event with a variable called enable. Simply, I'll get all the car materials and loop through them with a for loop to find the brake light material by name. I prefer to include the word brake in the material's name, so in the future, when using a different car, just having that word will make it apply automatically. After that, we'll use create dynamic material instance and connect it to the for loop, and most importantly, use set scalar parameter value afterward. Now, let's quickly go to the rear light material. Previously, we used a material collection, but now we'll replace it with a scalar parameter. And copy its name here. When turning on the brake lights, set the value to 1, and when turning them off, set it to 0. Connect it here and here. We'll copy the same setup into the vehicle blueprint as well. Good. Now both lights no longer turn on together. Let's check if the car lights up the rear lights when braking. Yes, it works. Now it's time to adjust the other effects for the car. There are a few issues, so I'll fix them and come back. Alright, I'm back. First, regarding the skid marks and sparks effects, they work perfectly fine and don't need changes. I also deleted the speedlines effect since it was useless. As for the sound, I found it needed adjustment. Here's what I did. In Meta Sound, on the right side, I deleted this option since it caused the sound to fluctuate. I did the same here. I also modified the sound attenuation to make its range wider. As for the sound here, I also adjusted the restart time. Why? Because if I didn't, there would be an annoying overlap and synchronization in the sound between the cars. That's it. Let's now do a final test for everything. In the next video, we'll discuss how to make the AI reverse and return to its correct path when it collides with an obstacle or finds the road blocked. Thank you for watching, and don't forget to subscribe.